Hello friends, Vidura here. A short experiment in the series of the parallel resonance circuit. Um, After the result of the last testing, I have concluded that it should be possible to do the same thing on the dielectric side of the circuit. So I have changed the circuit for this one. And what we do now here is instead of shorting the entire circuit, we will interrupt the capacitor side. We will interrupt it on the maximum voltage point at zero current, which coincides with the zero current point, of course. So it should be possible to stall the circuit like in the last experiment, but in this case to stall it at the maximum voltage and zero current point, while all the energy of the resonant circuit will be stored in the capacitor, and by interrupting this switch, it will be stored there for any time we will interrupt the switch. And after, it should resume the oscillation as in the last experiment, but in the last experiment the energy was stored in the inductor, of course. Okay, here the setup. I have put here this bidirectional switch in series with the capacitor. The other things are the same as before. The measuring shunts, the inductor is all the same. I have set the scope traces to the graticulate line. The lower trace is the voltage, and will power on. And as we see, the result is as expected. We can of course now see here in the off time of the tension of the voltage, the oscillation, the self-oscillation of the inductor in this interval. But we can see the current is switched off exactly at 0 point, at the current 0, and this time is extended by the value which we open the switch in this case and interrupt the. So here I have moved now the probe from channel 2 to the capacitor directly. I have moved them from the total voltage of the circuit to the point to measure only the capacitor voltage. And I put on channel 1 the driving pulse to see the relationship, the timing of the driving pulse. Okay, you can see now here. This is the channel 2, the voltage over the capacitor. You can see that in this time we have the resonant sine wave. In the moment there is the driving pulse, and nearly simultaneously with the driving pulse we open the circuit of the capacitor. So the voltage of the capacitor is stored inside of the capacitor and can't go any way. And when we close the switch again, so the cycle will resume at the same point, and the oscillation will go on the same point where it was interrupted here. So we can very similar with this technique extend the timing of a resonant oscillation by inserting or pausing it, so to say. Circuit. So very interesting technique, maybe, as we can play with the timing, with the phase relationship of reactive power, and I'm sure that something useful can be made with these techniques. Thanks for watching.